Hello, we will be talking about 2.7, proving statement relationships and properties of congruence. The reflexive, symmetric, and transitive properties of congruence are very similar to the same properties of equality. So we're just going to say they're congruent instead of equal. Segment AB is congruent to segment AB. When we use this a lot, if I have two triangles and I want, well, these, let's make them so they look like, if I have two triangles that are connected by a side they share, and we want to somehow prove that these two triangles are congruent, a lot of the times we have to say that that side they share is congruent to itself. That's when the reflexive property is going to come into handy. And then the symmetric property, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And finally, the transitive, if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So if we look at properties and say what justifies each, identify the property that justifies each statement, we're looking at statements. We have an angle is congruent to itself. That's the reflexive property. Measure of angle 1 is equal to measure of angle 2. So the measure of angle 2 is equal to measure of angle 1. Symmetric property of equality, of congruence. And segment AB is congruent to segment CD. Segment CD is congruent to segment EF. So segment AB is congruent to segment EF is the transitive property. Before we do this, I want to look at page 2. So we're going to come right back. Actually, just the beginning. Well, we can look at all of page 2. So if we look here, we are going to get a postulate that we haven't, or we have talked about this. We have talked about this. If I have two segments that are all on the same line and I add them together, the length is equal to the whole length. So if B is between A and C, then that tells me that the length of AB plus the length of BC is equal to the length of AC. And so if this is given, I can say that these two lengths sum is equal to the entire length. And the reason would be the segment addition postulate. Segment addition postulate most of the time is going to be used when you look at the picture. So it's always important to look at the picture. If I have a given where M is the midpoint of AB, when I know that M is the midpoint, that tells me that the length of AM is equal to the length of MB by definition of midpoint. And if I am told that the length of AM is equal to the length of MB, that tells me that M is the midpoint by definition of midpoint. So for the definition of midpoint, you can either start knowing that something is the midpoint or knowing that two segments are congruent, and by looking at the picture, you can see that all three of those points are collinear. Then you can also use definition of midpoint there. If a proof ever has this as the given, you almost always have to go to the two sides being the same length. Then when we have congruent statements, so if we know that the length of AB is congruent to the length of CD, because that's given, we can say that the length of AB is equal to the length of CD by the definition of congruence. When you are solving things, if we ever want to use addition, subtraction, multiplication, division, we have to have an equal sign instead of a congruent sign. So when you are proving things, if you are ever given that two things are congruent and you know that you're going to be using those other properties, you first need to state that their lengths are equal by definition of congruence. And then at the end of the proof, when you have that the length of AB is equal to the length of CD, you can then say, well, then therefore those two sides are congruent by definition of congruence. And we'll get to some examples with both of those. So let's come back to example 2 on that first page. So it's given that M is between N and O, between, not the midpoint, and that's different. So M is between N and O is our given statement. First thing almost always is given. If we see this, NM, the length of NM plus the length of MO is equal to the length of NO. Well, when we're proving things, we have to look and see what's above it. If I look above, well, I can also look here. The segment addition property tells me that these two things added together are going to be the whole. So the reason for this is the segment addition property. And therefore then, if I have this 2x plus this length, 3x minus 9, is equal to the whole thing, I have just substituted in there. Substitution and subtraction I like to spell out, because if you don't spell them all out, obviously you can't put SUB for both of them because that doesn't tell you if it's subtraction or substitution. So I like to spell those two both out to make sure I'm not making a careless error. Now we're going to be solving an algebraic proof. So what do we do first? We combine our like terms. So we have 5x minus 9 is equal to 4x minus 4. And just like I said, we did combine like terms. From here, I'm going to subtract 4x from both sides, leaving me with x minus 9 is equal to negative 4. So I use the subtraction property. Then I'm going to add 9 to both sides. So x is going to equal 5. And that was the addition property. I always want to make sure that this last line matches exactly with that. And it does. So we did prove what it asked us to prove. So we did page 2 already, so I'm going to skip ahead then to page 3. So on page 3, we are given that the length of JL is congruent to the length of KM. Those two are congruent. So this first step, like I told you, almost always is given. Then if I look here, it says the length of JL is equal to the length of KM. I only look what's above. I don't look at what's below. If I look from here to here, they're the same except I went from congruent to equal. So therefore, this is definition of congruence. And like I told you before, the reason we had to go to them being equal instead of congruent is because now we're going to throw some addition and subtraction in there. So the length of JK plus the length of KL is going to equal the length of JL. And the length of KL plus the length of LM will equal the length of KM by the segment addition postulate. And the reason we can put these on the same line is because they had the exact same reason. So then if I look here, well, look here. I have the JL, which came from here, and the KM, which came from here. So all I did was, instead of this JL was equal to all of this. So instead of saying JL, I substituted that into there. Instead of saying KM, I substituted all of that into there. So all I did here was I used substitution based on what was given and looking at this step. Then from here to here, if I look at this, I say, well, what's different from this step to this step? Well, we got rid of the KL on both sides. To get rid of it, it was being added. The opposite of addition is subtraction. So I used the subtraction property to subtract the length of KL from both sides. Then my proof statement is using congruent. So I went from the two lengths being equal to the two segments being congruent, which is definition of congruence. So a lot of times you will have definition of congruence twice in your proof. Okay, moving on. Example 2, given C is the midpoint of length A, segment AE, and C is the midpoint of segment BD. And we have the length of AE is congruent to the length of BD. Let's draw this picture. It should have been drawn in by the time this video is made. You may have a picture already drawn in, but if not, please draw. So we're going to have segment AE. We know C is the midpoint, and then C is also the midpoint of BD. So the picture should have been there if it was not. So if the first statement is given, we need to write all of that. C is the midpoint of segment AE and segment BD, and also AE, segment AE is congruent to segment BD. So we put all of the givens there. Sometimes you'll see the givens separated on two lines. That's fine too. Then we went to AC. The length of AC is equal to the length of CE, and BC has the same length as the length of CD. Well, if I look above, nothing above states that, but I do know that C is the midpoint. So if C is the midpoint of AE, it means that these two have to be the same length. Therefore, this is definition of midpoint. Then here, if I look up here, these two are almost identical, except this is congruent and that's equal. So therefore, remember that's definition of congruence. Here we're given the segment addition postulate. Well, by the segment addition postulate, I can say that the length of BC plus the length of CD is equal to the length of BD. And looking at the other one, I can say the length of AC plus the length of CE is equal to the length of AE. And we already had that rule. So therefore, if I look, I have this. I should have written that first, I'm sorry, is equal to this. So what did we do? We took, instead of the length of AE, we substituted this value in for it. Instead of the length of BD, we substituted this in. So we used substitution. Now we have AC, the length of AC plus the length of AC is equal to the length of CD plus the length of CD. Well, if we look up here, we know that AC and CE have the same lengths, so we just substitute it in there, and these two are the same, so we substitute it in there. So we have another substitution. Well, combining like terms, we know we have 2 times the length of AC is equal to 2 times the length of CD. Division property, we divide both sides by 2, leaving us with the length of AC is equal to the length of CD. Then we go to those two are congruent. Therefore, that is definition of congruence. We will practice more in class tomorrow before you're given anything, because I know these proofs are a little harder. So just try to get what you can, write down your questions, and I will answer them in class tomorrow. Thank you. Bye-bye.